let's see a problem on ladder friction. The question is, a ladder of length 9 meter and of weight 400 Newton is leaning to a wall and resting on a horizontal ground. The coefficient of friction between the wall and the ladder is 0.2, and that between the floor and the ladder is 0.4. Now in the figure, see, the head of the ladder is leaning to a vertical wall at the point A, and the foot of the ladder is resting on the floor at the point B. At the point A, the coefficient of friction is given as 0.2, and at the point B, mu is 0.4. The weight of the ladder is 400 Newton. The weight is acting at the centroid of the length. The ladder is 9 meter long, and at 4.5 meter, the self weight is acting downwards 400 Newton. And the question is, when a man of weight 900 Newton carrying a box of 108 Newton stands on the ladder at 2.54 meters from the top, the ladder just starts to slip. I repeat, when a man of weight 900 Newton carrying a box of weight 108 Newton stands on the ladder at 2.4 meters from the top. This is a point where the man stands with a weight. At this particular point of time, the ladder just starts to slip. The question is, determine the reaction between the ladder and the floor, the ladder and the wall, and the inclination of the ladder. The inclination is theta. So here, the man is standing at 2.4 meter from the top, and the man has a weight of 900 Newton and he carries a weight of 108 Newton. So this is the total weight which is acting at this point. The question is, find the reaction at A, RA is equal to what? The reaction at B, RB is equal to what? And what is the inclination of the ladder with the floor? Theta is equal to what? So this is the question. Now let's draw the free body diagram first. Consider the point B. So what are the forces acting at the point B? We have at the point of contact, the reaction, the normal reaction which is acting upwards, because the ladder is resting here and the weight of the ladder, a component of the weight of the ladder is acting downwards, which means that we have vertical reaction RB acting upwards, perpendicular to the plane of support. Perpendicular to horizontal means vertical. Now, when the man stands here, the tendency of the ladder is to slip towards the right, which means that the friction is acting towards the left. Friction is always acting along the surface of contact, along the plane, opposite to the direction in which the body tends to move. So FB is equal to mu B RB, or FB is equal to mu B is 0.4. FB is equal to 0.4 RB. So these are the two forces acting at the point B. Now consider the forces acting at the point A. The head of the ladder has a tendency to slip down, which means that the friction would be acting up. Similarly, the reaction at the point A would be acting perpendicular to the plane of support, which means horizontally as this. This would be RA, and the friction is acting upwards. Since the head of the ladder slips down, friction would be acting upwards. FA is equal to mu A RA, or FA is equal to 0.2 RA. So we have drawn all the forces in this free body diagram. What are the forces? The self weight 400 Newton acting at the midpoint, which means 4.5 meters from either end. The weight of the man together with the box acting at where he stands, that is 2.4 meters from the top. RB acting upwards. FB acting towards the left. RA acting horizontally towards the right. FA acting vertically upwards. FA is mu A RA, FB is mu B RB. So these are the sets of forces acting in this ladder. Now let's consider the equilibrium of the ladder when it just starts to slip. Equilibrium of the ladder. In equilibrium, we know that sigma Fy is equal to 0, sigma Fx is equal to 0, and since it's a non-concurrent system with the forces acting at several points, we can also say that algebraic sum of the moments about any point also would be 0. Let's consider the point B. Sigma MB is also 0. These are the three conditions of equilibrium. Now let's consider the first condition, sigma Fy is equal to 0. Consider all the forces acting vertically in the system. Let's take all the forces acting upwards is positive and downwards is negative. Now look at the figure. What are the forces acting upwards? RB is acting upwards. FA is also acting upwards. 900 plus 108 is acting downwards, and 400 is also acting downwards. So you can say that RB plus, instead of FA I can write 0.2 RA. RB plus 0.2 RA is equal to 1008 plus 400 is equal to 1408. That is your first equation. Sigma Fy is equal to 0. Second equation, third equation. According to 1, this is what? Now let's consider the second equation. Sigma Fx is equal to 0. Here you equate all the forces acting horizontally towards the right to those acting towards the left. What is acting towards the right? RA. What's acting towards the left? 0.4 RB. So according to the second equation, you can write RA is equal to 0.4 RB. That is your second equation. Start. Now, substituting the value of RA as 0.4 RB in this equation 1 and solving, you get RB is equal to 1303.7 Newton and RA is equal to 521.48 Newton. So the first part of the question is solved. The question was to determine the reactions of the ladder and the floor and the ladder and the wall. So RA and RB was found out. The second part of the question is, what is the inclination of the ladder? What is theta? Now, in order to find out what is theta, you can apply the third condition of equilibrium. Algebraic sum of the moments of all the forces in the system about any point is 0. We can take the moments of all the forces acting in the system about any point. If you consider the point B, you can take sigma MB of all the forces is 0 for equilibrium. For that, you need to find the moments, you need to find the perpendicular distances between the lines of action of all the forces to this point B. That is how you take the moment. Now, considering all the forces one by one, we'll take RA, we'll take FA, we'll take this force and we'll take this force and equate the moments of all these forces about B as 0. Of course, we have RB and mu B RB, but since these two forces are acting at B itself, they won't have moments about B because the distance between their lines of action to B is 0. They are acting at B, which means that their moments are 0. So, for taking the moment of RA about B, we need to find the perpendicular distance between the line of action of A and this point, which means that you need to determine this height. How do you determine this? To take the moment of RA about B, you have to find the distance from the line of action of RA. This is the line of action of RA. The perpendicular distance from this line of action to B. This is the distance you need to find to take the moment about B. Now, how do you find this distance? Very simple. This ladder is 9 meter long. This inclination is theta. So, what is this height? The height would be length 9 sine theta, and this would be 9 cos theta. Simple trigonometry. Alright. If this is theta, we have this right triangle with the hypotenuse as the length of the ladder, which means that this altitude would be 9 sine theta and this would be 9 cos theta. And to take the moment of this force about A, you need to find this distance, perpendicular distance from the line of action of the force to B. What is this? Consider this distance. This is 2.4 and the total is 9, which means that the balance is now, in order to take the moment of 1008 about B, you need to find the perpendicular distance between line of action of this force and this point, which is this distance has to be found out. What is this distance? This angle is theta. You can consider the small right triangle. This length is how much? From here till here it's 2.4 meter. The total length is 9 meter, which means that the remaining this much of hypotenuse is 6.6 meters, which means that this distance is 6.6 cos theta. Now, in order to take the moment of 400 Newton about B, we need to find the distance between line of action of 400 and B, which means that it is 4.5 cos theta. So we have 9 cos theta, 6.6 cos theta and 4.5 cos theta as the perpendicular distance between the lines of action of all these vertical forces to B. And as for the horizontal force, the perpendicular distance between this and this is 9 sin theta. Now let's take the moments about B. Sigma MB is equal to, first, the moment of RA about B. It makes a clockwise moment about B. RA being this about B, it has a clockwise moment. So it is RA into 9 sin theta. Now what's the moment of point 2 RA about B? That is again a clockwise moment plus 0.2 RA into, from the line of action of 0.2 RA, the distance to B is 9 cos theta. 9 cos theta. Now, what's the moment of 900 plus 108 or 1008? What's the moment of 1008 about B? It is anti-clockwise. So it is minus 1008 into, the distance is, this distance 6.6 cos theta. 6.6 cos theta. Moment of 400 Newton is again anti-clockwise, minus 400 into 4.5 cos theta is equal to 0. Calculation, you get this as 4693.33 sin theta is equal to 7514.14 cos theta. Now cross multiplying, you can see, get sine theta by cos theta. Tan theta is equal to something, from which you get theta is equal to 58.01 degree. So we have found the inclination of the ladder as well.